Okay, students, we'll talk now about conservation of linear momentum, which is in page 266. As you watch in the video, uh, that momentum, linear momentum, should be conserved if the external forces on the system are zero. Okay, now let us take this example to understand this point. If we have an object with mass m 10 kilograms and v initial is 4 meters per second, then after 10 seconds, this period, there is a stream of wind or something like that. Assume that this body is a boat or anybody effect with the wind or any other force. The mass of this body is still the same, but the velocity is increased to be 6, not 4, 6 meters per second. If we compute now the potential, the momentum initially, the momentum initially will be equal to mass multiplied by the initial velocity. 10 multiplied by 4, which is 40 meters per second. But finally, the momentum is 60 because 6 multiplied by 10 is 60. In this case, do we have any change on our momentum? The answer is yes. So in this case, we have delta P is equal to P final minus P initial, which is 20 kilogram meter per second. If we need to compute the external force, we know the relation between the Newton's second law and the change in momentum. The external force is equal to delta P over delta T. Delta T is 10, delta B is 20. Then the external force in this case is 2 newtons. So this external force, F external, is equal to 2 newtons. In this case, I need to ask this question: is the momentum conserved in our case? The answer is no. The meaning of conserved is that we need the change in momentum is equal to 0. In our case, the change in momentum is not 0. And we need also the external forces, the summation or the total external forces, we need them to be 0. But in our case is not 0. The forces is not 0. It is 2 newtons. But when P initial is equal to P final for the system, and that means the external forces, the total external forces is equal to 0, then the momentum is conserved. Let us see this example. If we have a boat in water, and this is a shore, the riverside or something like that, and we have a man need to jump from the boat to the riverside. If the mass of the man m naught is equal to 65 kilograms and the man jumps in negative x direction with velocity 4 meters per second, because it is a negative, we can put it negative 4. If we have the mass of the boat is 100 kilograms and the boat, logically, it will move to the right, to the positive x-axis direction. If this process takes 2 seconds, the time, what is the velocity of the boat? If you know that the velocity for the man v naught and the velocity of the boat vb are equal to 0 initially, so we have now 2 times. The first is initially, the second is finally. When the first one is before the jumping and the second is after or during the jumping. Okay, in general, we need our total momentum to be conserved. That means P initial is equal to P final. Okay, how much P initial? P initial is equal to mass of the man, m naught, multiplied by his velocity, v naught, initially, plus the mass of the boat multiplied by the boat velocity initially. The velocities are zeros. Then the total potential momentum, is zero initially. Okay? So, if initial momentum is zero, then the final momentum is zero also. What is the final momentum? The momentum finally is equal to mass of the man multiplied by his velocity finally plus mass of the boat multiplied by its velocity finally. It should be zero. From that we can find that the momentum of the man is equal to negative momentum of the boat after the jump. Okay, so 0 P finally, which is the same as P initially, is equal to the mass of the man. His velocity is -4 because it is in negative x-axis direction. The mass of the boat is 100 and we don't know the velocity of this boat. We need to find it. In this case, we will move this term to the opposite side. It will be positive 260 is equal to 100 v boat finally. Then we can find that the velocity of the boat finally is 2.6 meters per second in positive x direction. Positive x direction. We need to see that the velocity of the man is 4, but for the boat is 2. 4 and 2.6, because the mass of the man is 65, but the mass of the boat is 100. Then the velocity will distribute between both of them with respect to their masses. Okay. Now, I know that F external should be 0. But what about if internal? The internal forces, we see that the man act on the boat by a force from man onto the boat, and because of this force the man able to jump from the boat to the side of this river, and vice versa also. There is a force from the boat on the man because of the third Newton's law. Okay, can we compute the internal force between the man and the boat? Let me see. For the man has the delta v, change in velocity, which is v finally minus v initially. V finally is -4. The man jump in 4 meters per second in negative direction, but his velocity initially is 0. So delta v for the man is -4 because he was stationary, then jump in -4 meters per second. This is delta v. We can compute the acceleration because we have the time. It is 2 seconds. The acceleration in this case is -2 meters per second squared. The negative sign tells us the direction. Okay, how much the force from the man on the boat? Due to Newton's third law, the force should be in negative direction, because there is a force from man to boat and the force from boat to a man, to the man. The force from the man is equal to his mass m naught multiplied by his acceleration. His mass is 65, his acceleration is -2, but this is the force of the man on the boat. Should we put negative sign? This case would be equal to 113 newtons, but positive. So the force from the man on the boat is to the positive direction, positive x direction. Okay, this is internal force. I need to ask, what is the force from the boat on the man in the opposite direction? Remember Newton's third law? And from that you can be sure that the force is negative 130 newtons. So if we know that, we can be sure that the summation of the internal forces is equal to 0, which is equal to 130 plus negative 130, which is equal to 0. This is the force from man on the boat plus the force from boat on the man. It will be 0. For conservative momentum, the summation of F external is equal to 0. This is the most important thing. And we always have the internal forces are zeros. Thank you.